All right, guys, how's it going out there? Rooster in Tennessee, roostercb.com. And this is going to be one of our basic information slash topic of discussion type videos here. And I, as always, welcome any outside input from folks that are smarter than me or have more knowledge on this subject than me. We're going to kind of be keeping it very basic, um, in terms and discussion that someone that is new to the hobby or knows very little about the hobby can understand the concepts we'll be talking about here. I'm not going to be going in super amounts of depth or using terminology that the average operator won't understand. There are plenty of other videos out there with people that are certainly smarter than I am on the subject. I am not an amp builder, nor am I an RF engineer, nor do I claim to be. I'm a lot like a lot of you guys out there, just have been in the radio hobby for close to 25 years now, I guess. And the knowledge that I usually share is from experience that I've picked up along the way. So, that being said, you otherworldly experts, if you get in the comment section, try not to tear me down too bad and just add some pertinent information to this subject, and feel free to discuss it amongst each other if you'd like. Always like to be a hub of knowledge for people, even if I'm not the one providing the knowledge. But what I want to talk about with the hobby being more and more popular, and one of the main components of the hobby is amplifiers. So always get questions about different types of amplifiers because there are quite a few different ones to choose from. And what I have in front of me are several different of the finals that are used in these amplifiers, what generates power in the amp, which is the main component that makes the amp go. And they all have benefits, and believe it or not, they all have drawbacks, and we will try to discuss some of that. And again, keep it fairly brief and surface level of the characteristics of each. To start out, generally speaking, you have two types: your tube type amps and your solid state, which is solid state is going to be your transistors, your MOSFETs, your LDMOS, however you want to, different types of amps such as that are going to fall under the solid state category. Tubes, we've got some examples here in front of us from old school stuff to larger broadcast style tube in the back there, and they do come much larger than that. I assure you, have ran much larger than that and have seen much larger tubes than that one in the back. But that's a relatively large tube in the back, and we'll talk about it as we come to the subject. But we'll start out. We'll talk about the MOSFET style amps first. The two examples in front of you, one is one of the one on the right is a MOSFET final used in to upgrade the Striker radios, and the one on the left is I think that's a 9530. See, it's a ERF 9530, and for you guys that have the Longhorn type radio, or for those of you guys that run the Rocket boxes, as far as I know, they're still using that type of final. When I say final, I'm referring to what generates power in the amplifier. So that's when I use the term final, that's what I'm referring to. So the MOSFETs, they come in all different sizes, all different power ratings. These, I believe, are around 100 watts each, give or take. They're more of a higher drive, I believe, type MOSFET, but again, different ones take different amounts of drive. For the most part, in the CB application, especially the ones being used in radios and in the Rocket Box type amps, they're going to be 15 volts or less. They're going to want you to run those between 13 and a half and 15 volts. So what are some of the positive aspects of those MOSFET style finals? They're inexpensive. And they're relatively easy to replace. You don't have to have a RF engineer to generally work on those amps. most of your local CB shops will be familiar enough to work on them. They're easy to ship. Those amps are. They're lightweight. And again, the components inside of them are inexpensive. I think this 9530, last I checked, I think I sell them for $14 or $15 each. Something like that. I don't really recall. I'd have to look on the website, but they're cheap, being my point. Now, the drawback to that, every one of these has a drawback or multiple drawbacks and multiple benefits. They are relatively fragile. Some of them more forgiving than others, but they do not accept being overdriven very well. Okay, if you overdrive them, overvolt them, they're not very friendly to that. They will run very hot. Most of the MOSFETs will. RM Italy amps use MOSFETs. They are very durable, but they will run hot. I do encourage people, if you're running a MOSFET amp that does not have a fan on it, I would recommend running one because they are hot. And when they blow, they usually sound like a 22 firing off. So that's just the surface level stuff on the MOSFETs. Okay, we'll put those to the side. And again, guys, feel free to add any other information. I do like the MOSFET amps. To me, the RM Italys are the best made out there. I'm not going to use this as a platform to down talk any other amps that use the MOSFETs, but tried and true, I believe, bang for buck. The RM Italys, they are cheap, inexpensive, but they are very durable for MOSFET amps. Now, over here in front of us, I just slid into position here. These are what people refer to when they use the slang pillboxes, transistor amps, pillboxes, 2879s, 2879Cs. The predecessor to these were the Toshiba brand transistors, no longer being manufactured. Okay, there are some fake ones out there. For those that don't know, that's the people that buy them, the people that don't know. They do sell fake Toshiba transistors. Authentic ones, see if I've got one over here. Oh, I've got one off to the side here. You guys can tell that I don't do a lot of staging for these videos. Authentic ones that test good, even used ones, are going to fetch somewhere between $50 and $100. New old stock Toshiba 2879s are going to fetch, $200, $150 to $200. After they were stopped manufacturing due to being hit by a tsunami that destroyed the plant, HG came along. Now, we're not going to give a history lesson on HG, but for the high drive finals, you have two options, 2879Cs and 2879s. These are the most common used transistor out there right now. The benefit of them, you can run them, the 2879C, most people will run between 14 and 16.5 volts. They really start taking off after 15.5 to 16 volts is when you start seeing significant benefits from the 2879C. They do, generally speaking, about 20% more, give or take, than the standard 2879. It's what I refer to the regular base 2879 as a 2879 standard. For example, 4 of these in an amp is capable of somewhere between 850 and maybe 1,000 watts PEP, or peak power. 4 of these driven to max power, you'll see somewhere between 12 and 1,400 watts PEP with the max voltage and the max amount of drive. So there is a considerable difference. Both are good options. The purchase price difference between the two is around $10 each, give or take there. Hold on, guys. I got to silence my phone over here. It's surely going to go off. Okay, I've got it. I've got it on Do Not Disturb. So, now, speaking on these transistors, there are other ones that are lower drive. These are your kind of high drive transistors. Camera keeps falling down. You have 2290s that are lower drive, 454s, which are kind of a medium drive, and 1446s, again, a lower drive transistor. But these are your two main power transistors being used. Now, the benefit of them, they are relatively cheap. Okay? They're not what I would say cheap, ranging between $30 and $40 a piece, give or take, but they are relatively cheap. Run them on 12 volts, 15 volts, 16 volts, which means you can take them and put them in a mobile application and you don't have to run an external power supply or anything to boost the voltage up or any kind of special alternators or anything like that. You can just run them in a mobile, pretty easy peasy. In my opinion, they are a little bit more forgiving to being overdriven than these. However, they are susceptible to failure due to being overdriven or high SWR, which is your antenna means it plays a very important role. You can be a failure before you get started if you have a high standing wave on your antenna. Everybody needs to have an antenna analyzer or have access to one. I personally do not recommend running these transistors if you cannot get your SWR below a 1.3. Some people say a 1.3, but a 1 to 3, not a 1 to a 3.0 SWR, 1.3, if that makes it easier to understand. If you can't get your SWR lower than that, I do not recommend running these because the reflected power will end up burning them up. All right. Next, not pictured, I don't have one sitting here in front of me, is basically a souped up version of this. And they have become very popular over the last few years. CB and ham operators are generally behind the times a little bit when it comes to technology like that. So everybody's calling it the new technology, the future. And that is, if you've seen the LDMOS, 50 volt, some of them are 50 volt, some of them are 65 volt, 48 volt. They're basically a giant MOSFET type transistor, and they run, on higher voltage. Now, they are very tough in some respects, but they are also very fragile in other respects. They look about like two of these put together, if you can picture that, these LDMOSs. The drawbacks to them, obviously they take a good bit of voltage, which means you can't just simply throw one in your vehicle. You're going to need to run an external power supply and feed it with an inverter, unless you have another way to get your voltage up like that. Now, you could probably, wire batteries together in a certain configuration and get your voltage up and be able to run them. But a lot of people that run those in the mobile, they like to run an inverter. Plug a power supply into the inverter, and there you go. Because you have to have a power supply depending on the voltage that LDMOS uses, 48, 65 volts, 50 volts, what have you. Now, the benefit to those is they are extremely forgiving to high SWR. Other words, if you have an antenna problem, and let's say something freaky happens with your antenna, and you have a 2.5 SWR all of a sudden, guess what? You're probably not going to blow that amp up. They are very tough and very rugged when it comes to SWR. So that is where they are better than these. These are not going to be as forgiving. The drawback to the LDMOS that a lot of people don't understand, they have to be attenuated to how much drive you're going to put into them. So in other words, when these amps are being built, they're going to use a bird meter for a reference, and they're going to set it up according to the average power input or maximum dead key or carrier that you're going to put into the amp. Which means if your radio does a max amount of power of 10 watts average, that is how the amp will be designed and set up. That's how the input will be attenuated onto it to where you will get the maximum amount of safe power out of that radio. If you deviate from that recommended or required amount of drive, let's say your radio only does 7 watts average. You will see a steep output fall off from your amp. On the flip side of that, if you overdrive the amp by, let's say, maybe even 1.5 watts of average power, it will burn the transistor or the final up. It will burn that 50 volt final up. They are not accepting to being overdriven. Okay? A lot of people think they're this bulletproof, unbeatable device. That's what people refer to them as a device. They are not. If you overdrive them, they will blow. They are very drive specific, which makes it hard to cater to the radio crowd because, as you know, most of us have 10 different radios that we like to run, or 4 or 5 different radios, and every one of them does a different amount of output. Striker 955 is different than a Cobra 29. Cobra 29 is different than a Uniden, whatever. So you run into that issue with them. They are good, by the way. The cost of them, relatively inexpensive for the power output they do. For example, a single one of those can do 1,500 to 2,000 watts PEP. The cost to replace it is going to be around $200, give or take. So there's benefits and drawbacks. Okay, moving on. This is going to be a long video, guys. I can already tell, and I'm just keeping this surface level. Look, if I really wanted to get technical about it and bleed the video for time, you could have an hour-long conversation at least about every component that's sitting in front of us. This is just general information for the average operator. So in front of us, we've got many different types of tubes, and the slang you'll hear for this one and this one are steel tubes, because the metal, obviously, that's why they call them steel tubes. This is a heat sink here. Very, very, very accepting to high SWR. Used in radio broadcast, of course, much larger versions than this, but very accepting to high SWR. The drawback being that they require excessively high voltage to operate, which makes them dangerous, very dangerous, kill you dangerous. Okay. For the example, this tube, I think it can use, 7,500 volts going to it. That is enough to kill you very quickly and very painfully, should you run across the wrong side of it or not know what you're doing fooling with it. Now, what problem does that create? Well, it limits the amount of people that are going to work on them. If you're the average operator and you buy one, and for whatever odd reason you have trouble with it, well, chances are your local CB shop isn't going to be equipped to work on it. They're either going to be afraid to, or they're not going to be able to properly diagnose and work on it. So that cuts down, a lot of the crowd that wants to get these. They've been around for years and years and years. There are dozens, hundreds of different types of steel tubes. The two main categories that you'll hear them separated into are tetrodes and triodes. And generally speaking, just keeping it basic, your triodes are going to be your higher drive tubes, and your tetrodes are going to be your lower drive tubes. Tetrodes generally going to start with a 4CX250B low drive tube. Same kind of concept that we were talking about with the LDMOS amps, how they can be overdriven. They're set up to be drive specific. A very popular one is a 4CX800. Again, if they are built properly, they're drive specific. You can set them up to where 1 watt makes them do 3,000 watts. Or you can set them up to where 10 watts makes them do 3,000 watts. But this is a low drive tube example. It said 4CX250B. One of the smaller low drive tubes. 4CX800 is about 2 or 3 times as big as this and does, 3 or 4 times the amount of power. This is a 3CX4500 in the back. and it's a triode. It's, you know, relatively large tube that probably can do 20 to 30 kW PEP and, you know, 8 to 10,000 watts average power in that ballpark. A lot of people like the 3CX 3000, probably the most popular one. A lot of people, that's when people feel like they've made a step to get a big amp. That's probably one of the, you know, best bang for buck amps out there, 3CX 3000. You know, capable of 8,000 watts average, you know, possibly more if you want to put a lot of volts on them, 20 kW PEP, give or take. But very popular. A lot of your big boys, you guys here, that are talking on 6. If you ever venture down to 6, 11, even up on 28, a lot of those guys are running steel tubes. Okay, way bigger than this. Okay, some guys are running stuff like this, but a lot of them are running considerably bigger stuff. Can't really think of anything else to say about them right now. Again, drawbacks and benefits to all of them. Drawback on these being that they're dangerous, and getting somebody to work on them if they tear up could be difficult for you. Readily available. They take longer to produce. They're generally all custom built. So if you have a builder build one, a lot of times they'll want half the money up front. Not a lot of people are comfortable doing that. But they are very durable. And bang for buck for power output, once you get to a certain power output level and you want to become the top 5% in the hobby, that's your only option, or your best option. Now, this is a glass tube, 500Z, one of the most popular tubes ever made. They also use high voltage. Most people run them somewhere between 2,800 volts and up to 4,000 volts. Now, 4,000 volts, they can get a little bit scary because you're running them on the ragged edge. I generally would say stay between 2,800 and 3,500 volts. Each one of these, you know, ballpark estimate on the power output of around 500 watts average to 650 watts average, and around 1,200 to 1,500 watts PEP if you want to drive them hard. Now, the thing about these 500Zs, they'll keep climbing in power. I mean, if you want to drive 250 watts into one of these, one tube will do 2,000 watts. Now, how long is it going to last doing that? Not very. Same sort of benefits as the steel tubes, forgiving to high SWR, and that's basically any tube amp out there. They're going to be more forgiving to having a high SWR. If you have antenna trouble, they're not going to just blow all at once. The drawback is they're relatively expensive to replace, especially when you're getting into this family or the 500Z. 500Z is about $250, $275 a piece. Some of these tubes can range, you know, the steel tubes can range from $1,000 maybe for something like this, you know, up to some of the very large tubes that are, you know, $4,000 to $8,000 a piece. Several that are, you know, $2,000 or $3,000. So again, you're getting into the upper echelon in the hobby when you're dealing with that. 500Z, very good bang for buck, very tough tube. One of my favorite tubes ever made. I've had everything from a single tube up to a 6 tube. Personal preference, I would recommend staying between 1 and 4 tubes with them. 1 and 2 tubes being the best bang for buck. A lot of your ham radio amps would use a 2-tuber for a legal limit, 1,500 watt PEP, and they will cruise at that all day long. You can squeeze 1,500 out of one tube. Again, you start cutting into the tube life a little bit once you start getting over that 1,200 or 1,300 watt per tube mark. But that's my spiel on the 500Z. Other tubes that are in the family that I don't think are even produced anymore, I have a stack of them back here, are the 4-1000, 3-1000. They basically look like this, except they're very big. They're like 2 or 3 of these put together is kind of what they look like. Last but certainly not least, I just went in no specific order on these. In the tube family are your sweep tubes, which were used in the CB boom, your Makos, your DNA, Phantoms, Mavericks, and I mean, there's just all kinds of different brands of amps from back then. They're going to use some variation of a sweep tube, and I don't even, this is like a 6LF6, I think. What's this one? So yeah, this is a 6LF6. The 6 at the beginning of it is going to tell you the filament voltage. So like, let's say we had a 24 LF6. That's going to be a 24 volt filament. A 31 LF6 is going to be a 31 volt filament. They do run relatively high voltage. In most cases, not enough to kill you, but enough to hurt the hell out of you, to make you not want to do it again. 800 volts, 1,000 volts, 1,300 volts. I mean, it's getting up there into the hurt you pretty bad area, but most likely not enough to kill you. I'm not saying it can't kill you. Working on them, they certainly can, but they're generally just going to hurt you pretty bad if they get a hold of you. And that's talking about these sweep tubes here. There's literally thousands of different types. They used to use them in TVs, everything. Everything used to be tube powered back in the day. Not really anybody building new amps with them anymore. It's more of your vintage stuff that uses them. Old tube top radios will have them. Old tube top amps like the Mako that I just showcased yesterday. And they range in price. Some of them are $10 or $15 a piece, the ones that were used less. And then some of them can be $100 to $120 a piece. It really just depends. Guitar amps, I think, or something else that uses them. The power output on them can also vary. It depends on how many volts you put to them, what type of tube it is, and the durability of them can also vary. How forgiving they are to being overdriven. It really just depends tube from tube. Something like an 8950 or a 2057 is a very tough, rugged tube, and something like a 6JS6C that goes in a Yaesu 101 is more on the fragile side. It's not going to take being overdriven very long. So, do I recommend beginners getting involved with these? Not particularly. It's kind of a once you're in the hobby and established and you want to start venturing out to different equipment, maybe get you a sweep tube amp. Being that one reason with all the tube top amps, you have to manually tune the amplifier. And some of them have a warm-up time. It's not turn it on and it's already doing maximum power. That's your solid state and transistor amps. You don't have to tune them. They're pre-tuned internally. With your tube top amps, they're going to have external tuners, and to get the maximum output power out of them, you're going to have to tune the amplifier. That's not for everybody. Not everybody likes to do that. Some people aren't comfortable doing it. Makes them nervous. For whatever reason, they would rather just keep it simple and turn your amp on and off and go to talking. That's what your solid state stuff is good for. But guys, I could keep going with this. I mean, this is already a really long video, and hopefully it helps some people out there. I'm not doing this to toot my own horn or anything like that. Again, there's a lot of information that I'm leaving out, but hopefully if you're somebody in the hobby and you don't have a lot of knowledge about this, it can help you decide what kind of amplifier you want to buy. Again, there are benefits to each. I've owned at least one example or probably 10 examples of every kind in front of us here. So when someone tells you, this or that is the best way to go, there's really not a best. I mean, there's just not. There's drawbacks and benefits to all of them. You guys feel free to share in the comments what you think, extra input, anything that can be helpful to somebody, y'all feel free to share it. And again, this is just a brief, not brief at all, but just an overview of the main different types of finals or devices that are used in the amplifiers that we like to use. All right, guys, have a good one out there. Rooster in Tennessee, roostercb.com. As always, I appreciate the support, the business from everybody. Everybody have a good one. Catch you guys out there. See you. Bye.